Us?
No, sir.
Okay, so today we are going to start this preparation of Haloarenes. Preparation of Haloarenes. Now see, in preparation of haloarenes, first we are going to prepare from hydrocarbon. From hydrocarbons by electrophilic from hydrocarbons by electrophilic substitution. Basically, electrophile will substitute in toluene methyl benzene. This is your methyl benzene. And if you are going to react this with X2 in the presence of iron dark, that means the reaction is carried out in cold. The temperature is low. So you know what will happen with the help of this. There will be generation of an electrophile X plus, and that X plus will go. That X plus will go. You can see with respect to methyl, it will go at ortho, and with respect to methyl, you can say it will go on para as well. So there are two products that we are getting. P para halo toluene. This is your toluene, TOLUEN, toluene. So we call it ortho halo toluene, and we call it para halo toluene. And you know what? This will be your major product and this will be your minor product, because there will be force of the repulsion. A steric hindrance will be there. That's why it is minor and this is your major. Is that clear, both of you? Due to this reagent, there will be generation of an electrophile X positive, and that electrophile will attack at ortho and para. Let me know when you are done with this.
Done, sir.
Very good. Now see, for the next preparation we are going. Austin, are you done with this? Okay. The next preparation is from amines by Sandmeyer's reaction. Sandmeyer's reaction. From amines by Sandmeyer's reaction. Sandman reaction is a very famous reaction, named reaction, which will also you will study in amine chapter. So see, how do we prepare haloarenes from amines? So amine is basically, you can see this is your amine. That means its common name is ben, its common name is basically aniline. It is famous, quite famous compound, and its IUPAC name you can call it benzenamine. But now this aniline is treated as IUPAC name. First of all, we are going to treat this with nitrous acid. Nitrous acid, that means you can see sodium nitrite, and HX. When they react, they produce nitrous acid. In cold, this temperature, the temperature when you are carrying this reaction should be low, 273 to 278 Kelvin. That means 0 degree to 5 degree centigrade. Then there will be generation of disonium salt. There will be generation of disonium salt. You can see N will be converted into N2 plus and X minus. This is benzene disonium halide. Benzene disonium halide. And after getting benzene disonium halide, you are going to react this with Cu2X2. You are getting, after getting N2 plus X minus benzene disonium salt, you can call it, or benzene disonium halide it is. You are going to react this with Cu2X2. You will be getting halobenzene, and N2 will be released. X here can be only for chlorine and bromine. For iodine and chlorine, we will use another another reagent for this. Okay. For iodine, we just need to react with potassium iodide with benzene disonium halide. You will get uh, iodobenzene as well. Mom, are you done with this?
Yes, sir.
Okay. Now see, if you want to prepare iodobenzene, it's very simple. If you want to prepare iodobenzene, it's very simple. What you need to do is take this benzene disonium halide and treat this benzene disonium halide with potassium iodide, and you will be getting iodobenzene. You just need to do this. Let me know when you are done with this.
Yes, sir. Done.
Very good. So basically, this is how we prepare. There are only two methods in our syllabus to prepare the Haloarenes. Now, we are going to start physical properties of haloalkane and haloarenes. So first, we are going to talk about melting point and boiling point. It's very easy. Always remember that the concept is boiling point or melting point generally directly proportional to molecular weight. Directly proportional to molecular weight. And if molecular weight is same, that means the boiling point is inversely proportional to branches. If molecular weight is same, that means isomers will be there, or we can write boiling point is directly proportional to surface area. Surface area. I'm going to give you an example of alkane as well. Just wait a minute. Now you can see that if you have CH3, CH3, CH2, and then CH2, and then CH3, this is your butane. And I can write the butane as well as this. So see, both of them have same molecular weight. So this will have more boiling point than this because there is no branch and it will have more surface area than this. Is that clear?
Yes, sir.
So this is how we calculate the boiling point and the melting point. Let me know when you are done with this.
Done, sir.
Very good. Now you are going to arrange this in decreasing order of arrange the following in decreasing order of boiling point. So the first one is CH3, CH2, CH2, and CH2Br. And the second one is CH3, CH2, CH, Br, CH3. And the last one is CH3, C, CH3, CH3, Br. Which one will have the most boiling point? Very good, as Austin. What about you, Oma? Are you done with this? Austin, you gave the answer, right answer. Let's say this is your A, this is your B, and this is your C. Very good, Huma. So this is the right answer. Now, for Haloarenes, you are going to arrange for boiling point. Chlorine, chlorine, and chlorine, chlorine. This is your A, B, and then C. Are you done with this? Not CAB. Basically, the para position with respect to this chlorine will have the maximum. Then comes your ortho position. Then comes your para position. A, C, and B. This is the order of boiling point. This is the order of boiling point. If you are going to see the melting point, if you are going to see for the melting point, it's very easy as well. This para position will have the most melting point. Then comes your ortho position, and at last meta position. At last meta position. This is for melting point. Melting point varies because with this structure, the particles of this compound will be packed tightly as compared to this and this. That's why this order is very important. Let me know when you are done with this. Come on.
Yes, sir. Done.
Okay. Now we are going to do some practice of the question from this topic. So write a question. Arrange each set of compound in order of increasing boiling points. The first one is bromomethane. The second one is bromoform. The third one, chloromethane. And the fourth one, dibromomethane. Please do this first, and then we will go for the second part. Just wait a minute. I'm going to keep it A, then B, then C, and then D. So the answer that you have sent, C is the nose. C, then A, then B. C. Any answer, Austin, from your side?
Yes, Sumit.
Yes. But B, it's D. Very good. And then- Okay, first of all, it's correct. Bromomethane. Bromomethane, that means CH3Br, right, Umam? Bromoform, that means CHBr3. And chloromethane, that means CH3Cl. And dibromomethane, that means CH2Br2. As I told you, for boiling point, which is directly proportional to molecular weight, right? Please tell me.
Yes, sir.
So this will have the maximum molecular weight because 3 bromine is there. So it will have then you can see 2 bromine is there, then B. Now you can see CH3Cl, CH3Br, CH3 same, but bromine is present in the periodic table below the chlorine. So it will have more atomic mass. So molecular weight increases, then A, and then comes your C. Is that clear?
Yes, sir.
Now, the next part of this question is your 1-chloropropane. 1-chloropropane. After this, isopropyl chloride. Isopropyl chloride. And then 1-chlorobutane. 1-chlorobutane. Please do it. Let me know when you are done with this. Very good, ma'am. Austin, any answer?
One second.
B will not be the maximum. See, if I'm going to write the structure chloropropane, that means CH3, CH2, CH2, Cl. And isopropyl chloride, that means CH3, CH, Cl, CH3. And if you are going for one chlorobutane, it becomes, you can see CH3, CH2, 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 and then chlor. Now you can easily see that the maximum molecular weight will have this. So this C will be the greatest one. A, B, and C. Now you can also see that there is a branch in the B part. That's why surface area decreases and hence the boiling point also decreases. So, so, and there is no branch. That's why it came here and then will be there. Is that clear, Austin?
Yes, sir.
Okay. Let me know when you are done with this. Now moving to the next question. Next question is, which one of the which one of the following has the highest dipole moment? Has the highest dipole moment? Has the highest dipole moment? The option is CH2Cl2, CHCl3, and CCl4. Out of these three, which one will have the highest dipole moment? Are you done with this? Yes or no? Let me know. Will you be able to solve it?
No, sir.
Okay, see, it's very easy. First of all, CH2, Cl2 is there. So you are going to draw the structure. You have studied about the dipole moment in class 11th, chemical one. You know that this chlorine is more electronegative, so it will attract towards itself. This chlorine is also more reactive, it will attract towards itself. Carbon is more electronegative, so it will attract from hydrogens, and in the same way, it will be like this. So there will be some dipole moment. There will be some dipole moment. In case of CCl4, if we are going, so it will be chlorine, 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 chlorine. And you can see it will attract towards itself. It will attract towards itself, and this will attract towards itself. This will attract towards itself. So here the dipole moment becomes zero. And if you are going for this, you we did this, and mu equals to 0 for CCl4. If we are going for CHCl3, you can see hydrogen is there, chlorine is there, chlorine is there, chlorine is there. Now, if you are going to see, chlorine will attract towards it, attracting towards itself, and this is also attracted towards itself. So in the same direction, most of the chlorine is going. You can see this. There is only two chlorine and there is three chlorine. That's why CHCl3 will have maximum or highest dipole moment. Is that clear, all of you?
Yes, sir.
Please. Right. Let me know when you are done with this.
Done, sir.
Very good. Now I'm going to give a very good question about the reaction that we have already completed. Let's see who will solve first. The question is basically a hydrocarbon C5H10 does not react with chlorine in dark, but gives single monochloro product. Monochloro compound C5H9Cl in bright sunlight. Identify the hydrocarbon. Identify the hydrocarbon. Will you be able to solve this? Yes or no?
Trying, sir.
Let me know if you're not able to solve this. Austin, any answer? Mom.
Okay.
Okay, see, this is your C5H10, and if you are going to react this with chlorine in dark, the reaction is not taking place. The reaction is not taking. But if you are going to react this C5H10 in sunlight, that gives energy H nu. Sunlight is there, then the reaction takes place and gives you C5H9Cl. Chlorine will react with hydrocarbon. Sorry, just wait a minute. Chlorine will only react with hydrocarbon in the presence of sunlight when this hydrocarbon will be an alkane. Will be an alkane. But the formula, but the formula, if you look at it, it will look like alkene, alkene's general formula. So with this formula, one alkane is possible. That is your cyclopentane. If you are going to check it, you will get it has C5H10, cyclopentane. And when you are going to react this with chlorine, one of the hydrogen you can replace from anywhere. The same product you will get. So it will be like this, a single monochloro product. So the hydrocarbon is your cyclopentane. So the hydrocarbon is your cyclopentane. Is that clear?
Yes.
Please do write it. Let me know when you are finished with this.
Done, sir.
Very good. Austin, what about you?
Done, sir.
Now see the next question. Write the isomers of the compound. Isomers of the compound having formula C4H9Br. We are going to write the isomers of the compound. Also name it. Also write IUPAC name. IUPAC name of H. I think you can do this, right? Will you be able to do this?
Yes.
Hmm. Very easy it is. Why are you taking too much time? Mom, are you able to solve this?
Yes, sir.
Okay, how many isomers you have drawn?
4.
Two. Two I've from.
Okay. Austin, how many isomers of C4H9Br will be?
4.
4. So the first one is very simple and you can write it in a straight chain like this CH3, CH2, CH2Br. What is the name of this? Bromo, butane or 1-bromobutane you can write? Now, for the next one, we can do it like this CH3, CH2, and then CH, and there is Br and CH3. Now, its name is 2-bromobutane, right? 2-bromobutane. Another we can do is like this CH3, CH, and CH3 there, and then comes your CH2Br. So if you are going to number it, it's very easy. 1, 2, 3, and the name will be 1-bromo 2-methyl, 1-bromo 2-methyl propane. And the last one, which is very easy as well, you are going to do this CH3, CBr, CH3, and CH3 as well. Both the branches on same carbon. So the name you can see 2-bromo 2-methyl propane. Is that clear, both of you?
Yes.
Yes.
Now, can you tell me the degree of halogen here? Primary, secondary, tertiary. This is your primary. This is your secondary. This is your secondary. Again, this is your primary, and this is your tertiary, right? Yes or no?
Yes.
Yes.
Very easy it is. Please do write it. Let me know, Humam, when you are done with this. Austin, each and every isomers are correct, and the IUPAC.
Yes, sir.
And Humam, the two isomers that you have drawn is correct.
Yes, sir, it's good.
Okay. Let me know, Humam, when to change the slide.
Done, sir.
Very good. The next question is about the reaction that we have already studied. The question is, you can see, write the equation. Write the equations for the preparation of 1-iodobutane. 1-iodobutane from. You need to prepare this 1-iodobutane from. The first one is 1-butanol or butane 1-ol, you can say. From also from you need to prepare 1-iodobutane from 1-chlorobutane and 1-chlorobutane, and also from but 1-ene, that means butane. Please Do it. I'll come first. Any answer? Let me know if you are not able to solve this. answer is the first one. Two-step reaction. No, it's a single step reaction. See what the question has been asked. One butanol, and you are going to prepare one iodobutane. See how we are going to prepare. Simple. Butanol has a structure. One butanol has a structure CH3, CH2, CH2, and CH2H. And you have seen a lot of methods to prepare haloalkane from alcohol. So I'm going to just use red phosphorus in the presence of I2. Simple. So what will happen? This alcohol, this OH will be replaced by what? This OH will be replaced by I. Now you can see iodobutane. You just prepared. Yes or no?
Yes.
Yes.
Please do it. Are you done with the next one?
Yes.
What about you, Humam?
Yes.
One chlorobutane. You can see one chlorobutane. This is your one chlorobutane. Now, if you want to prepare one iodobutane, so you can use Finkelstein reaction. NaI in the presence of dry acetone. Dry acetone. And you can get halogen exchange will take place CH3, CH2, CH2, and also CH2, and then I. And as a byproduct, there will be NaCl. So this is what we wanted to prepare. Are we done with the third one? Yes or no? Are we done with the third one? Both of you.
No, sir.
Okay. Will you be able to solve this? Yes or no? One but one in that means CH3, CH2, CH, double bond, CH2. Now you want to prepare this CH3, CH2, CH2, and CH2I. This is iodobutane. So what you need to do? Anti-Markovnikov, apply anti-Markovnikov. What you need to do? Just treat this butene. Just treat this butene with HI in the presence of peroxide. If in the presence of peroxide, what it is anti-Markovnikov in which negative will go to that carbon which has a greater number of hydrogen and positive to that carbon which has lesser number of hydrogen. And according to that, you can see you will get CH3, CH2, CH3, CH2, CH2, and then CH2I. Got it?
Yes.
Please do write it and let me know then. Are you done with this?
Yes, sir.
Okay. Now I'm going to give you some more reaction. The question is, write the structure of the major organic product in each of the following reactions. First, I'm going to give you three, which is very easy. CH3, CH2, CH2, Cl. And you are going to treat this with sodium iodide in the presence of acetone, and you are heating. The second is CH3, CH2, CH2OH plus SOCl2. first one is 1 chloropropane. No, the first one is 1 iodopropane. Okay, any answer from you, Humam?
Yes, sir. 1 minute.
Okay, take your time, but do it correctly. Very good. It is again the Finkelstein reaction. You can easily go for this Finkelstein reaction. So, hello, exchange of halogen will take place, and you will get CH3, CH2, CH2I. And the byproduct will be as it is NSE. So, iodopropane or 1 iodopropane. For the next one, you can see this chlorine will replace this OH group, and you can see what you will get. You will get chloropropane, and the byproduct will be SO2 as well as HCl, which will be in gaseous state. So, out of all the preparation of haloalkanes from alcohol, this was the best preparation. Is that clear, both of you?
Yes, sir.
Okay, very good. CH3, CH2, CH, double bond CH2, double bond. Just wait a minute, please. Double bond CH2, and you are going to react this with HBr. This is your peroxide. Are you done with this? Very good, Austin. Any answer from you, Humam, for this one?
No, sir.
Okay, see, this is your alkene reacting with HBr in the presence of peroxide. That shows it is anti-Markovnikov. If peroxide is not there, then it is Markovnikov. And what does anti-Markovnikov says? It says that negative will go to that carbon which has greater number of hydrogen. The bond will be broken, and this will go to that carbon which has lesser number of hydrogen. So it will become CH3, CH2. It has CH, now it becomes CH2, and it has CH2, now it becomes CH2Br. So it is bromobutane. Is that clear?
Yes, sir.
Very good. Please do write it. Now the next. The next reaction is CH3, CH double bond, C, CH3, whole twice, and you are going to react this with HBr only. do it correctly. Are you done with this? Are you done with this, Austin or mom? Am I audible to both of you?
Yes.
Okay. So see how you are going to do it. Can you recognize the reaction? You can see, you can write this like this. Alkene treated with HBr, that means it is Markovnikov. Markovnikov. And what does Markovnikov says? It says that negative part go to that carbon which has lesser number of hydrogen and positive part to that carbon which has greater number of hydrogen. So the product will be, it becomes CH2 from CH and it will be single. CH3 is as well as here and CH3 is also here, and here it comes. Is that clear, both of you?
Yes, sir.
Yes.
Okay, please do write it. And in the next class, nucleophilic substitution reaction we will start. Nucleophilic substitution reaction. You will study about this at home in the next class on Tuesday, SN1 and SN. Please read about this. Let me know when you are done with this. Is that clear? So this is it for today. I'll see you in the next class. Thank you.